Okay, let's just dive right into this explainer by asking ourselves a pretty fundamental question. How do we actually know what we know? I mean, we live in a world that is literally overflowing with data, claims, and theories. But why are some sciences incredibly precise while others seem, well, kind of messy? Today, we're going to dig into some really fascinating lecture notes that break down the exact step-by-step toolkit researchers use to separate fact from fiction.
Here's our roadmap for today's explainer. 1. Theory and scientific deviation. 2. Defining the scientific method. 3. The 5 research steps. And 4. Key characteristics of science.
All right, on to section 1, theory and scientific deviation, perfect versus messy. Let's lay some groundwork here and look at how science actually attempts to explain the world and why the real world doesn't always want to cooperate. At its core, any scientific pursuit has to begin with a theory. According to our source material, a theory is simply defined as something that can be used to explain a phenomenon. It's basically our baseline framework. You see something happen out there in the real world, and you construct a theory to explain why it happened. But here's exactly where things get a little complicated.
This comparison right here reveals a huge problem that researchers face. When we look at natural sciences, like physics or chemistry, the phenomena are everywhere, and they are always the same. Gravity is going to pull an apple down the exact same way here as it does on the other side of the planet, right? But when we switch to social sciences, like demography, which is the study of human populations, it's not everywhere the same. Human behavior introduces what these notes call deviation. Simply put, sometimes people just don't act the way the theory predicts. They're unpredictable. Which brings us to section 2, defining the scientific method. Finding truth in the mess. Since fields like demography are so prone to this deviation and error, we clearly need a really rigorous system to manage all that messiness.
Looking closely at our source notes, these are from Lecture 4, dated May 17, 26. There's this incredibly powerful statement just hidden in the handwriting. It says, "Science is distinct because of its methodology." Really think about that for a second. Science isn't defined by what you study, whether that's microscopic atoms or massive human populations. It's defined entirely by how you study it.
So the crucial takeaway here is that the scientific method is defined as a systematic study of a subject matter within a given scope. And there's a massive caveat you got to catch. The problem you're dealing with must be clearly defined before you start working on a scientific system. You can't just, wander aimlessly into a sea of data and see what happens. You absolutely have to define your target first.
Moving right into section 3, the 5 research steps, the detective's toolkit. Let's actually open up this toolkit and look at the practical, on-the-ground steps required to execute one of these systematic studies.
Our source notes lay out exactly 5 steps for doing real scientific research. We've got observation, recording, classification, generalization, and verification. These are the foundational steps that take us from just casually looking at a messy world to actually proving a scientific truth.
Let's jump to step 1 and see how this all builds. It all starts with observation, which is essentially just collecting your data. But the notes specify that this starting point requires you to minutely observe the subject matter. So this isn't a casual glance as you walk by, it is a deep, highly focused examination.
And you execute this observation using your 5 sensory organs, right? Eyes, ears, nose, tongue, and skin. But the notes make a really specific distinction here that I absolutely love. The eyes are considered fundamental. Seeing is the primary, totally essential way we gather the raw data of the world around us for scientific study.
Okay, so once you observe, you hit step 2, recording. You have to make a careful record of your observation. But, and here's the hardest part for literally any human being, you must do it without any personal bias. You can't record what you want to be true. You can only record what is actually there.
To pull that off and record without bias, researchers use a really fascinating concept called the sociological imagination. The notes define this as looking with a completely new perspective, seeing the surrounding world like a stranger. Imagine walking into your own house, but looking around as if you had never, ever been there before. That is the exact level of detachment you need to record pure, unbiased data.
Once you've got this pure data, you reach step 3, classification. This is where you categorize all the collected materials based on similarities or differences. To wrap your head around this, just think of a simple everyday analogy. It's exactly like properly organizing a messy wardrobe or a filing cabinet. You put the shirts with the shirts, the pants with the pants. You are literally creating order out of chaos.
To underscore just how important this wardrobe sorting step really is, the notes reference this great 1892 quote from the mathematician Karl Pearson. He said, "The classification of facts, the recognition of their sequence and relative significance is the function of science." So science isn't just about collecting a bunch of random facts. It's the actual act of classifying them and recognizing how they all relate to one another.
Right, so after your facts are all nicely filed away, you move to step 4, generalization. This is where the scientific system attempts to find a common rule. You look at your classified matter, and you search for a semblance, like a pattern or a similarity. This common rule is what ultimately builds out a scientific method.
Let's look at a concrete example provided right inside our demography notes. By observing, recording without bias, and classifying demographic data, researchers found a semblance, which led to a generalization. They found that educated women generally tend to have fewer children, while uneducated women tend to have more. This is a common rule extracted directly from massive amounts of otherwise messy human data.
Finally, you hit step 5, verification. The notes emphatically label this step as an absolute must. You have your shiny new generalization, but you have to verify it continually. It is strictly necessary to preserve the scientific nature of the entire study. Because, honestly, without verification, a theory is really just a guess. Section 4, Key Characteristics of Science, the Mindset. Let's wrap up our explainer today by zooming out and looking at the overarching mindset required to apply these 5 steps effectively, especially in fields that are prone to all that messy human error we've been talking about.
But before we list the final characteristics of science, we have to return to this lingering question that the notes pose directly. Why exactly is demography considered a weak science compared to something rock-solid like physics?
The answer written in the notes is just beautifully blunt. It has some errors. That's it? Because it deals with human beings who constantly show deviation from theories, demography is just never going to be mathematically perfect every single time.
But you know what? That weakness is exactly why the scientific method is so incredibly powerful. Because there are errors, science has to be dynamic, meaning it actively improves over time as we verify and correct our generalizations. It must rely strictly on logic, and the research methodology must be entirely systematic. It has to move relentlessly, step by step, to catch and correct those deviations.
Science isn't some magic wand that perfectly explains everything on the first try. It's a gritty, rigorous toolkit designed to find order in a very messy world. So I'll leave you with this thought. Knowing that data, especially about human beings, inherently contains errors and deviations, how will you use this 5-step detective's toolkit? Observation, recording like a stranger, classification, generalization, and verification to find the actual truth in the headlines you read tomorrow. Stay curious, keep classifying your facts, and I'll catch you in the next explainer.